Well, it's Wednesday. You know what that means, Jody, right? Time for another
Time to
edition
get smarter
of Morse Code of Weather with meteorologist Jacob Morse.
We got another history lesson today.
I love it. Great.
We went way back in history last week. This will be part 2 of this little mini-series about weather forecasting history. We talked about weather forecasting before the 1950s, going all the way back to Aristotle in 340 BC when they were coming up with some of the primitive thoughts of weather forecasting and what is going on with our atmosphere. But as we went through time, we developed instruments that could measure things with our atmosphere like thermometers, barometers, and the like. But it really did not get going until the 1900s because we did not have ways to solve these very complex equations that physicists came up with that dictate the way that our atmosphere behaves. So we needed something a lot more powerful to solve these complicated equations, and we got that in the 1950s with the introduction of computers. Now, the electronic numeric integrator and computer, ENIAC, was invented in 1950, and the first weather forecast created using this computer was made in Princeton, New Jersey by the Institute for Advanced Study. Now, these computers were not very fast, but they were able to solve those complicated equations in a faster way than just humans could, in a way that was faster than the atmosphere moved, so that we could actually get a usable weather forecast from them. Now, they weren't very accurate at that time, but they have slowly made advancements since that introduction of the computer in the 1950s. Now, the Weather Bureau, which was the predecessor to the United States Weather Service that we now know today, they adopted numerical weather prediction in 1955. So now we could start to communicate these weather forecasts that our early computers were creating. With the introduction of radars, as well as the introduction of satellites, this was the radar network in the 1950s, that was providing these weather computers with a lot more information. The more information that they are fed, the more accurate that their forecasts can be. So when we have these satellites that were introduced, this first weather satellite was in 1960, that allowed us to get a lot more up-to-the-minute observations about what our atmosphere was doing. With that data, the weather forecast models could then help to predict the future. The way that these numerical weather forecast models work is on a grid system. So in the 1950s, the grid spacing was very large. We're talking 200 kilometers by 200 kilometers. That's a very large area that you're solving those mathematical equations for, and the resolution is very coarse. So you cannot pinpoint the weather information as closely as we can today with our much more advanced weather forecast models. These grids are 3 kilometers by 3 kilometers, just a couple of miles apart, that we have weather data that we solve for. So those equations are solved for each one of these grids in a 3-dimensional space because the atmosphere goes thousands of feet up. So all of those equations are solved for temperature, pressure, etc. in order to figure out what's going to happen in the future. Again, for each one of these grids. So when we were looking way back in time, each one of the spots that the computer was solving those equations for was really far apart. So we've drastically improved our spatial resolution, but also the temporal resolution, which means how quickly the forecast updates. So now we're creating forecasts minute by minute out into the future. Now, the way that weather forecasting works is it operates on chaos theory, meaning that a lot of things can happen wrong in the future, meaning that if we solve those equations out in time, a lot of differences can happen from one run of those equations, one run of the model to the next, just based on how complex our atmosphere is. It's the butterfly effect. If there's a butterfly that flaps its wings 100 miles away, that could cause some weather event to happen downstream, just based on how connected our atmosphere is and how small changes can impact what's going to happen in the future. But all of the weather data that we get nowadays with our observation systems allows our initial conditions, what those weather forecast models are being fed, to be a lot more accurate. So all that data is a lot more valuable. And now we have the most advanced supercomputers to solve those equations. These new supercomputers were introduced earlier this year and can solve the equations that dictate our atmosphere in 2.8 quadrillion calculations every second. And they're continuing to be advanced more and more with each upgrade to these supercomputers. These computers are in the top 50 fastest computers in the world. That just shows how much computing power we need in order to solve these complex equations that dictate our atmosphere. Now this graph's a little complicated, but the takeaway message is that a 7-day weather forecast today is as accurate as a 3-day weather forecast was in 1990, showing how we've improved our weather forecasting accuracy over the years. And it's just amazing how far we've come in such short of a time. So you go from 1950 to today, 72 years is how long numerical weather forecasting has been around, and how much more we can improve it in the future is just amazing with the computing power that we have available today.
Interesting.
It is so interesting, and the atmosphere, it's a fluid, right? So there's so many things that can go wrong. I really picked up on that butterfly effect, because one little something rather somewhere can dictate what happens globally.
Right.
I mean, when it comes to equations and solving the atmosphere. It's a fascinating look at how we've progressed over the decades and centuries.
And we take it for granted a lot of times.
We
Just
sure
pulling
do.
up our app,
Yep.
Firstborn
Yep.
Weather app, hourly forecasts. Imagine telling that to someone in 1950 that we could have that today.
Well, they said it was going to be windy today,
Right.
so that's what it all comes down to,
Yeah,
right?
they said you
Right.
got it right. Thanks, Jacob.